now, so it should be, yeah, it's ready to go.
Okay. Now I'm going to share that document again. So I'll put that up there. Can you see that?
Yep.
Yeah, all good.
Now I've just got to get you back on the screen again. Yeah, right. I'm getting used to it. Okay, so last week we finished with construction program. So we're up to design criteria. We're now getting to the point of doing the heat loads, or cooling loads and heating loads. Dua, you've done some of these, but Jelen, have you had experience with heat loads yet?
I did a while ago, but not since my return.
Okay.
Yeah.
All right, well, this is pretty basic stuff, and it's just a lead into how we go about it. So design criteria is the first thing. Usually, if you have a specification for a project, the design criteria will be shown there. The things that you need, the outside ambient conditions, excuse me. It might be specified, but when you're using the Camel program, it will come up. You select the area that the building is in, and it will give you the conditions for that area. But sometimes it'll be specified differently, higher. Perhaps for a hospital, they might specify higher conditions. But also in the area handbook, there's a list of all the conditions for different cities around Australia and other countries. The inside conditions may be specified in a brief, if you've got the design brief, or the specification. If there isn't a brief, we can nominate the conditions based on the type of space and area guidelines. For different types of buildings, they have different design conditions. So a hospital will have a design brief, and for different areas, operating theatres, wards, all the different areas might have different conditions. So you need to be aware of that and apply the correct conditions. For a commercial space, normally we would nominate 24 degrees Celsius and 50% RH for summer and 21 degrees for winter. That can vary, but it is something you need to discuss with the client and agree on that. Ventilation, we need to know what the ventilation rates are for the various processes. Again, for a commercial building, you'll have outside air intake and toilet exhaust, and there may be other exhausts required. The ventilation rates could be specified in a brief or specification, but they have to comply with AS 1668 Part 2. So that's obviously an important document. Now, there are lots of other things that you need to do when you do a heat load, but before we talk about that, talk about zoning. Dua's aware of zoning. We've talked about that recently. Do you know what I mean by zoning, Jelen?
Not really, no.
It's basically breaking up an air-conditioned space into different areas that are going to have different responses to the heat inputs. So, for instance, I've given an example here for an office building where you've got windows around the perimeter, and then you've got an internal area as well. You'll have perimeter zones and internal zones. And the perimeter zones are the ones, so I've got west perimeter, east perimeter, north perimeter, south perimeter. That's the basic 4 zones, but you may have corners as well where you have an intersection between 2 zones. That needs to be treated carefully because sometimes you just make that a separate zone, depending on the size of it. And we had, Dua and I had one we talked about last week where it was or let's say it was a northwest corner. I'm not sure that was what it was, but if it was a northwest corner, if it's not a very large space, you're better off to treat that with a separate unit, because otherwise you have conflicting zones requiring different temperature responses. The perimeter zones are affected by what we call fabric loads, which is solar radiation and transmission through the windows, and transmission through the walls and the roof, maybe the floor if it's exposed. And these need to be applied to all the zones. Now, I've said refer to diagrams. I don't have any diagrams to show you, but we can talk about this some more if you need to. If you've got a heat load to do, the best thing is to sit down with somebody and discuss how it should be zoned. So you can talk to me or Phil or Ivan and work out how it should be zoned. But they're the basic concepts anyway: perimeter and internal zones. Now, getting onto the heat loads, you need to collect or measure a lot of data, and probably request information for certain data. Again, Dua, I think you were trying to collect information last week. Sometimes it's not easy to get, but to do the heat load accurately, you need to get this data, and you need to get that right. Now, you can run the heat load with preliminary data. The longest time is taken by actually entering the data. So you can put something in, you can do a preliminary load, and when you get the correct data, then you can replace the data you've already got. Excuse me, need a drink. So usually we normally use Camel for the heat loads. That's the standard in Australia. There are other programs that you can use, but Camel is the one that we use, and it's been proven over, well, probably 30 years now to be a pretty reliable program. You can do it manually as well, but it's very time consuming. But it's worth knowing that the Error Guide DA09 sets out a manual method of calculating heat loads. So we'll probably talk about this later on in a different session, but previously I had a couple of sessions on heat loads with the other guys, and we went through DA09 chapter by chapter, because they had a particular interest in having the background to the heat loads. So doing a heat load is not that hard once you've got the data and you understand how to input it into the program. It's quite, I won't say simple, but it's not a difficult process to do a heat load. But you also need to understand what you're doing, because if you don't really understand the information you're putting in, you're not going to understand the results either, probably. So DA09 is a good one to look through just to get the manual method and where all this information comes from, because Camel is basically written around DA09. So that's where it's come from. It's in your files. You can have a look at that when you have some time. Now, the sort of data that you need to be able to calculate, to do a heat load or to input into Camel, there's a list here: project location and building orientation. The orientation obviously is important because our largest perimeter heat loads are on the east and west, so you need to get that orientation correct so that Camel can calculate the loads correctly. Design conditions required for each zone. We talked about that in design criteria. Outside air flow rates required for each zone. The zoning drawing, which I mentioned before. Once you get the architectural drawing that you're going to calculate the heat load for, that'll be one of the first things you do, is work out how you're going to zone it. And it's a fairly simple process. work out the floor areas per zone, the ceiling heights. You need to collect the information, the insulation details for walls, roof, floor, etc. And then you can work out the U values. I'm sure Dylan knows what a U value is. Dylan, do you know what I mean by U value? Sorry, I can't hear you.
Sorry,
Yeah,
no,
okay.
no, I don't. Yeah.
So you're not aware of the U values?
No.
Okay. A U value, well, you can look up the definition in ERA, DA09 as well, but it's basically the coefficient of thermal transfer.
All right.
So that the equation for heat transfer through a building element is the U value, U times the area times the delta T.
Okay.
So UA delta T.
Okay.
It's a simple way of putting it, but the solar effects have an effect on the actual temperature difference. So that you can calculate an equivalent temperature difference which takes into account the solar radiation on the surface. That's a whole separate subject, and we can go through that another time. But when you use Camel works that out for you, so you don't need to worry about that. So we've got external walls. This should be specified in a brief or the specification, but quite often it's not. And quite often it can change during the course of a project. I've worked on not a lot, but a few projects where the glass performance has actually been changed. And the reason it's been changed is because the builder or somebody else has decided that they can buy cheaper glass somewhere else. And so just be careful of that. If that happens, that affects your heat loads. But at the start of a project, you need to establish what the U values of the walls are. You might have to calculate it, or it might be given to you. There are standard wall types in Camel that you can select. So say it's a brick veneer with internal insulation in the wall. Those sorts of things are all listed in the Camel program. The windows are probably the trickiest one. The windows have a U value. They also have a shading coefficient or solar heat gain factor. That's really important because the solar load is the most dominant load, certainly around the perimeter. In the centre zone or internal zone, that's not affected by the windows, but around the perimeter zones, the windows are the important thing. So you need to, if you don't have that information, you need to request it and confirm that it's correct for the project. That project that you were working on, Dua, did you get the information that you were looking for on the glass and so on?
Nothing.
Nothing yet.
The project manager's been struggling to find any fit out info, but we need to move forward with whatever we have and assumptions we did.
Okay. So how did you work out the U value and shading coefficient for the glass in that case?
We're not intending to do heat load calculations in detail using Camel. We're just gonna focus on zoning and units distribution based on the rough calculations we did, at least at this stage, until we receive information.
Okay. All right. So it's with glass, you can get a very wide range of U value and shading coefficient. You can look at glazing and say, oh yes, that's double glazed. It should have a U value of, let's say, 0.5. No, sorry, no, it'll be more than that. So 2.5, or it might be as high as 4. And the shading coefficient might be as low as 0.3, could be as high as 0.7. So it can make a huge difference. So it's really important to try and get that data when you're doing a heat load. Otherwise, your results could be completely wrong for that building. You've got internal partitions in the building. If you have areas that are not conditioned next to areas that are conditioned, you'll have a heat load through the partition, and Camel can deal with that. But again, you need a U value for the partition. Normally, they're just the plasterboard with a timber frame. They may have insulation inside, so it's easy enough to calculate the U value or pick that out of the Camel data. You need to know the occupant density per zone. So how many people, in other words, in each zone. Information is available in OS 1668 about people per square metre, if you don't know what it is. Quite often there'll be a drawing, an architectural drawing with seating arrangements, which will tell you how many people there are. And so you can apply that to the zone. The lighting intensity, there might be a lighting layout that you can count up the lights. You need to know what the output, the heat output of those lights is. Again, that's another question you might have to ask. It's not always given to you. The NCC in section J has a list of maximum watts per square metre for lighting intensity. I think it's J6, but don't quote me on that, but you can look it up. It's the electrical section. So for an office building, for instance, it might be 10 watts per square metre. For a shopping centre, it might be 20 watts per square metre. So in the absence of any other data, you can use that, but it's best to check it or to ask the question, because it can be as low as, for an office building, might be as low as 5 watts a square metre. And obviously that makes a difference, because if you're going from 5 to 10, you're doubling the intensity of the heat load, and again, you might be oversizing. There's a focus towards energy efficiency now, and that's why the NCC has specified maximum values, but quite often they're less than what the NCC have actually specified, because lighting is improving all the time to keep the to improve the efficiency. And each zone will have equipment. Most people have a computer on their desk, so that's a heat load. It might only be 150 watts per computer, but it needs to be included. Now, all these things, ideally, this list of all this data would be in the design criteria. If you write a reverse brief, which is back to the client, which is a good thing to do on any project. If you're going to do a heat load, write a brief of what you've based it on. And you can list all these things out and say, we've based it on a certain U value for the walls, a certain U value and shading coefficient for the glazing, so many people per square metre. All these things are the basis of your calculations, and need to be clearly stated and agreed to cover yourself, really. Because if you submit that to your client and say that's what we based it on, they say, okay, that's fine. And it doesn't turn out to be the correct data later, then at least you've said what you've based it on. You can't be blamed for getting that wrong. Any questions?
No, that's pretty clear.
Okay, well, I was just talking about computers there. The other items that are found in a typical office space, printers. There might be an air-conditioned tea room that's got little ovens and things. They're only used independently anyway, so they don't really create much of a heat load. But the things that are operating continuously, computers and printers and those sorts of things, need to be considered in the heat load. And when you work on other buildings, say for instance, well, a kitchen, you might do an air conditioning of a kitchen. There's a lot of heat producing equipment in there that needs to be looked at in detail. Or a laboratory or a hospital, all these different areas. They have equipment that emits heat and needs to be taken into account. So no questions. We'll go on to heat load output. So the Camel output, you would have seen a Camel output doer, I guess. Jelen, you probably haven't. So it's probably a little bit hard to discuss this without having had a go at it. But just in terms of process, which is what we're talking about, we'll go through it anyway because it's just part of the process. So Camel gives you a big range of data, and in particular for each air-conditioned zone, you'll get the following information. You get the cooling and heating loads for each zone, which is the amount of cooling and heating required. You'll get the supply air and return air and outside airflow rates for each zone. The supply air is obviously the conditioned air from the air conditioning unit. The return air is what's recycled to the air conditioning unit, and the outside air comes in directly from outside, mixes with the return air, and becomes the supply air. Camel will tell you, based on the calculations, what the resulting temperature will be in the zone and the relative humidity. So you need to look at these things and be happy that that's what you want for the project. You put in the data, you put in the design criteria saying that you want, say, 24 degrees and 50% RH, but Camel might come back with something different. So you need to have a look at that and decide whether that's acceptable or whether the input data has got a mistake in it. So you need to go through the results and be satisfied that what you've got is correct. Now, I mentioned last week that you'll also get check figures coming out of Camel, such as for the zone, the watts per square metre or litres a second per square metre. You need to have a look at those as well and just be happy that that's what you would expect. I mean, you might say for an office building that you'll expect 120 watts a square metre, say for an internal zone, and Camel comes back with 50 watts a square metre. You'd say, well, that doesn't seem right. Okay, so then you go back and have a look at your input data and see if you've made a mistake putting data in. I think I mentioned to you once before, a project in Queensland, a young engineer got a result of 1,000 watts per square metre. And I said, well, that's not right, it can't be right. It turned out that there was an input of, can't remember the figure exactly what it was. I know it was to do with lighting. So instead of 10 watts a square metre, the input was 100 watts a square metre or something like that. So you can find that, you can go back to your input data and say, oh, that's not correct. Change that. It's a very simple process to make the change and run the program again. Camel also gives you psychrometric charts. We'll talk about those in more detail. Are you familiar with psychrometric charts, Stuart?
I am, yeah.
Okay, so this is another big subject that we'll talk about later on, but it's quite important. So Camel will produce a psychrometric chart. It also produces tables of loads at all hours of the day, every hour of the day, for every day of the year. So if you want to look at a particular day, or have a look to see when the peak is occurring and what's happening either side of the peak, those tables are in there as well. So there's a lot of data that you can look at. But the basic data, it gives you the capacities and the airflow rates. And from that, you can start to produce some equipment schedules. So initially, the equipment schedule would be something that you could, for instance, put together a preliminary equipment schedule to send out to a supplier or two suppliers to get competitive quotes. So that might be your first step. At one stage in my career, we were doing D&C work exclusively, and we would be quoting a job nearly every day. So in a year, I think one year we did 400 quotes for D&C jobs. So we were doing more than one a day. And so we do a heat load. I'd always do a heat load, work at what equipment we needed, put it on a schedule and send it out so we can get prices for that equipment. And also for the fans, for the outside air, for the toilet exhaust, all those things. We need to produce schedules to get prices. So once we've got the pricing back, we will also get the technical data for that equipment so we can put the data on the schedule as well. Have you done a bit of scheduling? Either of you do, or you would have done some scheduling, I presume?
Yeah.
And John, have you done a bit of scheduling?
Yeah.
Okay. So these are very important documents, and they carry right through the project. So once we've got all the data for the equipment, we've selected what we want, we can put that on a schedule and submit it for approval. We're a client. If they come back and approve it as is, that's great. We can then turn that schedule into a construction issue. And it's issued to drafting, so they know what they have to draw. It goes to site so that the people on site know what equipment is going to be delivered to them and what has to be installed and where. And the commissioning people get that as well, because then they know what they have to commission. They know the details of that equipment. The schedule, I'm actually talking from the point of view of a contractor here. It's not, this is something that we do for a contractor. And then the contractor would include the purchase order, include the schedule with the purchase order, just to confirm to the suppliers what we're asking for. And then the schedules during construction, there might be some changes. Some units may be changed, some may be upgraded. So things do change in the course of a project, can change. They don't always change, but they can. So the equipment schedules need to be updated with any changes. And on some projects, the things that probably change more, fans might be changed if they find that they need to upgrade them, or you might have to add fans or take fans away. On big projects, this is quite normal. It's changing quite regularly. So you need to keep updating the equipment schedules, because that's a current record of what's actually going into the project. So they become very important. For someone to pick who doesn't know the job, for instance, can have a look at the equipment schedules and very quickly get an idea of exactly what equipment is in the job. If you don't have that, you've got no idea. And at the end, after it's been updated during construction, it can be updated again to an as-built or as-installed issue and inserted in the operation and maintenance manuals. Again, for future use, when people come to maintain the project, they can see exactly what's in the project. So I'll just finish off this session. The last paragraph there, the equipment schedules will require an estimate of the fan static pressure to enable the supplier to select the correct fan. So initially, when you get a quote, you don't necessarily need that. But when you're going to submit it for approval and for construction, you need to have calculated the fan static pressure to have all the details you need to order that equipment, whether it's an air conditioning unit or a fan or, you know, anything with a fan in it has to have a fan static calculation. And you both know what fan static pressure calculations are because we've been talking about those. We can talk about that a bit more later. So if you like, we can finish now. It's half an hour.
Yep. Thank you so much. That was amazing.
Okay. Any questions?
No. That's,
All good.
yeah.
Okay. All right. Well, just contact me anytime if you've got something you want to talk about.
We will. Thank
Okay.
you.
Thank you.